For 32, what is the complex conjugate of each of the following? So the complex conjugate is going to, the first number stays the same, and the second, we take the opposite. So the 3 stays the same, and the opposite of positive I is just a minus I. So the complex conjugate of 3 plus I is 3 minus I. Here, the negative 5, the real part stays the same, and the imaginary part, just take the opposite. So it would stay negative 5, and the opposite of a negative I would be plus I. So let's add one more example. Let's do 2 minus 7I. So the real part stays the same, and then we take the opposite of the imaginary. So the opposite of negative 7I would be plus 7I. Alright, for number 20 we're going to simplify, and you could multiply the 20 in as your first step, but I'm not going to do that because I want to keep the numbers small. And so now here's an example where we'd use the complex conjugate. This will get rid of the imaginary number in the denominator. So we're going to multiply top and bottom by 3 minus I. So let's see here. I'm going to leave that 20 where it is. And so 7 times 3 gives me 21. 7 times negative I gives me minus 7I. And now the negative 2 times 3 gives me negative 6I. And then the negative 2 times the negative I gives me a positive 2I squared. And so now on the bottom, so instead of distributing this one, I'll use the box method as review. So we have a 3 plus I, a 3 minus I. So the 3 and 3 makes 9, plus 3I minus 3I minus I squared. So now combine your like terms. So now I'm going to have 9. These are opposites, so they're going to go away. Minus I squared. Alright, we can clean up this a little bit here. Now remember that I squared equals negative 1. So this is going to be 2 times negative 1. So this is actually going to become negative 2. So it's going to be 20. And then this 21 minus 2 gives us 19. And now combine the negative 7i with the negative 6i for a negative 13i. And then like up here, this I squared is going to become a negative 1. And so this negative negative is going to actually turn into a plus 1. So this is going to become 9 plus 1, which is just 10. So now we can reduce our fraction. 10 is going to go in the 20 2 times, and so I'm left with 2 times 19 minus 13i. So if this isn't one of the possible answers, you could try multiplying the 2 in, but more than likely this will be the answer because we want it in simplest form, so we'll factor out the GCF. Alright, 34, what is a conjugate, or what's a complex conjugate? So like we already talked about, the real number stays the same, so it's going to be 9, and then we take the opposite of the imaginary part, 9 minus 7i. Alright, what value of c makes the equation true? So I want to, let's just go ahead and rewrite the left side and simplify and see what happens. So I'm going to want to distribute the negative 3 in. And so I get 5 minus 6i, negative 3 times negative 4 is plus 12. Now combine your like terms, so 5 and 12 makes 17 minus 6i. And so now I'll go back to the question, because there's nothing else I can do here. We want to know, so the left side simplified to this, and the right side given was 17 plus ci. So c is just a unknown. Well, now we know what it is. So c would be negative 6. Uh, 36, right? The polynomial function with the 0, 0, 3, 2i, and a negative 2i. So these are our solutions, our zeros. And so what we can do to get our factors, if we write them all out, x equals 0, x equals negative 3, x equals 2i, and x equals negative 2i, and then we undo it. Well, there's nothing I can undo here, just x. But here, if I add 3 to both sides, we get x plus 3 equals 0. And so that kind of shows why negative 3 is our 0. Now this is the factor we're going to use. And so you can kind of see what's going to happen over here. We're going to minus 2i, and we're going to have a factor of x minus 2i. Here we'll add 2i and get a factor of x plus 2i. And so we want to put all this together. So we have the x plus 3, we have the x minus 2i, the x plus 2i, and then we have this 0. Well, that's just x. So go ahead and, when you simplify this, you'd want to simplify the imaginary first, because you should notice that this is a complex conjugate. So as you multiply these, if you want to do the Mach's method, that's fine, but x and x is going to make x squared. X and 2i is going to give us positive 2i. Negative 2 and 2i and x is going to give us a negative. I forgot the x there, so 2xi. So now we're going to have a negative 2xi, then a negative 2i plus 2i, or multiplied by 2i gives us a negative 4i squared. And so these are opposites, so they're going to go away. And remember, I squared is negative 1, so this here is going to become a positive 4. And so this multiplies to x squared plus 4. Here we can multiply these together and get x squared plus 3x. I just went x times x and got x squared, x times 3 and got 3x. And so now let's review the box method to multiply these two things together. So I have two terms and two terms, so 2 on top, 2 on the side. So x squared and 3x, x squared, 4. So now multiply them together. X squared and x squared makes x to the 4th. X squared times 3x gives us 3x cubed. 4 times x squared gives us 4x squared. And then 4 times 3x gives us 12x. So you'll notice there's no common terms, so we're just going to rewrite it. So our function is going to be x to the 4th plus 3x cubed plus 4x squared plus 12x. And so finally at 37 we have the negative 3 plus 7i squared, which is just negative 3 plus 7i times negative 3 plus 7i. So you can distribute this out. You can do the box method. Doesn't really matter. That's going to give us a positive 9, negative 21i, negative 21i, and positive 49i squared. Now, since these aren't complex conjugates, you're gonna still have that middle term with just the I. So now we combine, and so the negative 21i and negative 21i is going to give us negative 42i. The I squared becomes negative 1, and so negative 1 times 49, this whole thing becomes negative 49. So negative 49 and 9 gives us negative 40. Now, if you remember my shortcut, we square. So negative 3 squared is 9. We multiply and double. So negative 3 times 7 is negative 21 doubled is negative 42i, and then we square. So that gives us positive 49i squared. Same thing, this becomes negative 1, this becomes negative 49, 9 and negative 49 gives us negative 40 minus 42i. It's great if you remember the shortcut, but if you don't, you can always just expand it and multiply it out.